So if we have perfect squares, we are able to undo perfect squares by square rooting. So if we can factor a trinomial into a perfect square, such as a plus b all squared, we can solve these by square rooting these. So if we take a look at the quadratic here, because this is not a perfect square form, so we don't have the square here, we've got a square here, we've got x here. It's not in the perfect square form. It's hard to solve this by square rooting. However, it can be converted into a perfect square form because this happens to be a perfect square. And if we have x plus 7 all squared, this is a perfect square. If we were to draw this out, this is going to give us a square shape. Same with x squared plus 2x plus 1. It can be factored and arranged into a perfect square shape. Therefore, we can write it as a perfect square. And since we have a perfect square, we can undo that square by square rooting. So to do this then, we need to make the square just as we did when we were doing the graphing form of the parabola. So what we want to do is find the piece that makes up the perfect square. So if I start with x squared plus 10x, to make a perfect square, I have to arrange the x parts symmetrically. So I need 5x here, 5x here, and that last piece then is going to be what completes the square. So this is going to be a 5 by 5 square. Okay, so we're going to have x plus 5, x plus 5. So to complete the square, we need 25 to complete that square. Here, to make a perfect square, it's a little bit awkward to make a perfect square with a 3x squared. So what we want to do first is we want to factor out the 3. And now it would be easier to make our perfect square with the x squared 4x. When we have an x squared and 4x, we're going to symmetrically distribute the 4x into 2x and 2x. And that allows us to complete the square. We take half the middle and square it to get our perfect square. Okay, and then this can be factored into our perfect square form. So we end up with 3x plus 2 squared. Here we end up with x plus 5 all squared. So this gives us our perfect square. Now we can undo these perfect squares algebraically by square rooting. So this is what we want to do here. We have now an equation. I want to solve for x. I want to undo this square. If I want to undo this square, I have to make this into a perfect square shape. So I'm going to do this. I'm going to do x squared minus 8x plus blank. Okay, and what I'm going to do is on the left hand side, I want to make my perfect square. So I end up with x squared. I have minus 4x, and to complete that square, I need 16. Okay, so I take half the middle and square it. The problem is that this equation is not balanced, and so we're breaking one of the most important rules of algebra, which is balance. So I need to make sure that I keep it balanced by adding 16 on both sides. So now I have a balance. Again, I can do anything to equation as long as I keep it balanced, which I have. And now I want to try to solve this. Well, I can't undo this square with the x there. However, if I can rearrange this into a perfect square trinomial, so x minus 4 squared, I can add that together. I get 31. I can now solve for x. I can get rid of this square by square rooting. So we have to be careful though, when we square root both sides, I'm going to end up with plus minus. Okay, so we have to make sure that we keep that plus minus. So now that I've undone that square, I can just solve for the x by itself. So add 4 to both sides, so I get 4 plus minus square root 31. And just as a side note here, notice that the 4 happens to be where the vertex is. If we're thinking of vertex form, notice that 4 happens to be the middle of the solution of the zeros. We're going to start at 4, we're going to go plus root 31. We start at 4 and go minus root 31, so we know that the symmetry of the zeros are about around that number 4. Okay, so this one here, again, it's going to be a little bit hard to complete this square with a 3 there. So what we want to do is factor the 3 out. Okay, and now we want to complete the square. So we have our x squared, we have our 3x and 3x. Okay, since we're trying to make a square, we need to symmetrically distribute the 6x into 3 and 3. To complete this square, we need 9. Okay, so now I've completed the square, but I've unbalanced my equation. So I need to rebalance this not by adding 9 to this side. How we've actually added 3 groups of 9, so I need to balance this with 3 groups of 9, which is 27. Now I've got this balance. I can make this into the squared form. There's my perfect square, which I know how to undo. I cannot undo this square here because of that extra x. However, now I can free up the x by square rooting since it's in a perfect square form. So this becomes 29. Divide both sides by 3. Okay, and then I can solve this by square rooting. So I end up with x plus 3 is equal to plus minus square root 29 over 3. And then solve for x. X is equal to negative 3 plus minus square root 29 over 3. And notice again that in the perfect square form, we did this to find the vertex of the parabola. And notice that the location of the vertex, the x-coordinate of the vertex, shows up in the solution. And it's the middle of the solution because we're going to start at negative 3, which is a vertex, and go left this much, and we're going to plus that much and go right. So we know that the solutions, or the zeros, are symmetrically distributed about negative 3, which is our vertex.